You can see here a lot of different. Oh no! This magnetic field then induces from inside. Let's open power supply. You can see. Hi, I'm Zachary Burda. In this video, I will show you my process of writing a bachelor thesis at Aalto University. I will explain what the bachelor's thesis is, tell you about my project, and give some tips that can help you writing your thesis. Let's get into it. A bachelor thesis is a research project at the last year of bachelor's program. It's a great opportunity to take the stuff you learned and put it into practice. At Aalto University we have a 10 credits course that helps students to write their thesis and give some feedback on it. At the end of the course we present our thesis work and results to a responsible teacher, instructor and our peers. It also includes answering questions about own thesis and asking some questions about results of others. The first step was to design and 3D print the transmitter frame. After that, the frame should be wired. Okay, so currently I'm wiring the transmitter system. Here's 8 structures where I should put wire on, and also there's some special pads for receiver. From the side, like this. Also, when this will be done, I need to do tuning for transmitter and for each of the receivers. And yeah, it takes a lot of time. Right, by the way, here's my previous prototype before this one. As you can see, this one was designed with hiding the wire inside in mind. It was the main goal of these big structures, 3D printed structures. The main problem was that the gaps here wasn't even, and like some of them are bigger, some of them are smaller, and also wire, it's not in the right shape. And here is a receiver from the previous build. So you can see here's a wire, it goes out from here, and here's some capacitors soldered. The new one is wider and a little bit slimmer. Actually, wiring this receiver is harder than I thought. So because of that, I need some kind of structure that will hold it and some pliers to push the wire inside the special path. Yeah, it will take some time, and unfortunately it's not this easy. Plus the wire is pretty stiff. Yeah, it's like 2 millimeters. Yeah, I will have a lot of fun here. Let me explain how this magic of wireless power transfer happens. First, let me introduce the receiver and transmitter circuits. The transmitter circuit on the left has a coil and AC current source. R1 and R represent resistance in wires. Capacitors in the circuits are essentially the compensation networks that tackle apparent power in the circuits and thus improve power transfer efficiency. So, how the magic happens? AC current source, or the transmitter, creates a magnetic field. This magnetic field then induces an AC voltage on the receiver circuit's coil. And this is exactly how power is transferred wirelessly from one circuit to another. Okay, let's see what I got. The end result looks like this. And I got the coil to the path. It was pretty hard. And here we got 2 wires coming in and coming out. We will just put it like this into the path, design path, and this is receiver.
2 hours later.
2 receivers. Currently, I'm doing the receivers. I need to solder these parts to them and then some pins that looks like this, like this, and it will go in some kind of this way. So I put the pin, this piece, and then solder them. Then I can measure inductance and do the tuning. And also transmitter, the same here. Okay, never mind.
And now you can see the process of measuring the inductance of the coil.
So capacitance for transmitter and two receivers is calculated. I need to add now capacitors to the circuits. Also, I need to resolder a little bit, but it will not take a lot of time. Here now I should find some capacitors I need. First I need to do the calibration, and then I can measure each of them, and now I will check how much of capacitance I should add or delete from the circuits I have. The results are kinda looks like this. Yeah, so not the most clean solder. Now I need to measure what kind of self resonance they have. Depending on this, I need to change these capacitance. The setup looks like this. Here's my transmitter, which is connected to the vector network analyzer. It is calibrated already, and here we can see the resonance frequency, resistance. So I did the measurements and I got the number that I didn't really expect at all. And after investigating the cause of this, I found out the capacitors were not soldered right.
It took some time to tune the compensation network of the transmitter and both of the receivers. When this is done, it's time to test the system and see how it performs.
Here the first setup, the first test with the one receiver, and here the oscilloscope and power supply. Currently the input voltage is 10 volt and input current is 0.353 ampere, and as you can see from here, I'm not sure if you can see, the output current is 0.5 and output voltage is about 5 or 4.9. Efficiency is about 70% of the first test. Is much more bigger than the efficiency of the first prototype. Here the setup, the load for the receiver, rectifier. Here we measure current and voltage of the output. So it's connected to the receiver oscilloscope. Here the power supply. Currently we are not testing anything, but we can turn it on. Here is the second load, a rectifier. Yeah. So first the third one and then the first one. Here you can see it goes 10 volt and the current is 0.4. Here's what kind of curve we get. And here the voltage and current of the receiver. At 10 volts, the efficiency of this receiver, it was about here 10, about 72%. It is pretty good. So now we're running the test with 10 volts and two receivers. This one gives us an efficiency of about 48%. There's a little bit drop compared to the one receiver. But we also noticed that with increasing the voltage for two receivers, efficiency goes up. For example, in this case, with 20 volts, we are getting already about 58% efficiency, and with 30, it was over 60, about 62.5% efficiency. And that means that it's really good idea to test with one receiver and 30 volts and to see what kind of efficiency there will be. So, when all the tests are done, it's time to finalize my bachelor's thesis. I will present all the research, measurements, results, tests on the paper. Then I need to prepare for the seminar. Then I can return my bachelor's thesis for evaluation and upload the ready work to the university database. Now it's time to give you some tips on writing the bachelor's thesis. I have 4 tips. Start earlier. The earlier you start, the better. You're not gonna have enough time anyway. Do good research. To write about the topic, you need to understand it. Devote enough time to study the topic broadly. Third, make the topic of your thesis specific. The too broad question gives an unspecific answer. It's easier to search and write if the research area is restricted. And the last one is to write something no matter how good or bad it is. Sometimes good ideas appear foolish in the beginning. Be creative and remember that you can always delete the unnecessary parts at the end. This video is done in cooperation with Aalto University, and in the video description you can find links to Aalto University website and YouTube channel. Thank you for watching. If you find this video useful, don't hesitate to like, subscribe and check out my other videos.